So about this presentation, and maybe about myself, I'm working in GlobalLogic for less than a year, but I'm kind of a C++ enthusiast. Even though I'm working in the automotive industry, doing outsourcing job, there is no much possibility for me to go deep into the language work. So I'm doing that a lot as an overtime, as my hobby. And therefore, I wanted to show something that is really nice about the new standard book, because probably you are not being able to see that when you are just doing the work. And I really realized that there are some things that it's hard to comprehend when you are doing some, the life after work. So today I'm gonna speak something about C++ concepts. And why concepts? So basically we are in 2020 right now. This year hasn't been great. So a lot of bad things happened. So pandemic and other very, very bad things. And this is just May, not today, tomorrow. But for the C++, it is a great year. We are getting very nice features, which were looked forward for many years. There are I would say 3 main pillars for the C++ this year. One of them is our coroutines. They are great. Maybe someday I'll create a talk about them, but they are definitely more complicated than concepts. In addition to that, there are modules. So hopefully we'll get something about the compilation time issues for the C++, because the compilation time is a great feature, but then it is annoying if you have to recompile the project and let's say the CMake didn't cache everything, and then you need to wait a few hours. That's terrible. So modules might do something about that. And last but not least, there are the concepts. And ranges, but ranges are based on concepts, but they are worth to be taken a look into. So today, what I'm gonna speak about is just the brief history of concepts, because they are here with us for a tremendous amount of time. I'll say something, why do we need generic code? I'll show something about the current state of templates, and then I'll show how we can shorten that with concepts. When I was trying to create a talk for 2 years, so I really got into concepts like 2 years ago, but I didn't have much time to go deep down there. I have some repositories about creating code with concepts, and my first idea was to show you the code, but then I realized that there is no way that I can comprehend that amount of information in one presentation. So maybe next time I'll create hopefully next time I'll create a next presentation in which I won't have any slides, because I'm terrible at slides. You can see there is a white screen and a black font. I really don't like it, but this is me. The console is best for me. And then I would like to, in that talk, and I would just go through object-oriented pattern. I will show you why this is not good. And in most cases, I will show you how it can be transformed into, let's say, C++ world of C++ 17, so concepts less. And then I will show you why this is bad still. This will be a little bit covered in this talk as well. So there are some things you don't need to know about the templates, because as we are all probably, or most of us working with C++, then there are very dark corners of templates, and no one wants to go there. Concepts are connected with templates very strictly, but they can be, they will be a successor. And in my opinion, I would say that generic code should be far more used than it is used right now. But what you don't really need to know about in this presentation is template metaprogramming, which is probably one of the hardest things in C++, for the beginners especially, because there are some nits and bits and the code is not very readable. And even though we have great advantages, of which I will speak later, there are terribly big amount of just the boilerplate and things that are hard to comprehend. Spine is part of template metaprogramming, but it is a big chunk of it, so I just made an additional point about it. And the type traits. Type traits are the basis of every constraints made for the C++ type, and template metaprogramming and Spine is based on that. But it can be used without it still. So, a little bit of the history. We have 2020, as I said, and concept just arrived this year, and they are not even yet standardized, I would say. The standard is still in the draft position, but it will be standardized. It will be standardized this year, so this is not kind of a thing that can be postponed. It is a certainty. So that's the first thing. And the second thing is that the concepts were accepted there, but the beginning about concepts reaches down to 1970s. So it is even before Haskell. There is a guy, Alexander Stepanov, of which I really encourage you to read any of his books. Elements of Programming is just really great. He is the father of the STL. So he coined their idea, I wouldn't say a concept of a concept, but idea of a concept. And concept is thing, I will speak about it later, but concept is a thing that puts a constraint about the type. So you can just say that something meets some boundaries. So it was 1970s, and then later on 1990s and late 20s, late 2000, early 2000s, sorry, and late 90s, he was creating talks which were then converted into elements of programming, and he really gave the fundamentals about the concept. The Bjarne Strostrup defined concepts in 1994. It was the design and evolution of C++. There was a very, even though we say that C++ is a lot behind and was a lot behind, maybe not right now, in terms of other languages which are fairly used, like, I don't know, Java or C# or Python. They have a lot of features that C++ don't have, but in fact, C++ was defining them back in like 90s or early 2000s, or even the late of 80s. So like Auto was added in C++ 11, but it was defined in 90s by the Strostrup. So this is kind of a background for the concepts when it was created. And then the concepts, the work on concepts has been started around early 2000, and Alexander Stepanov created a working group. There was Andrew Sutton, Bjarne Strostrup, and other guys, Sean Parent, for example. And then they created a first working draft of a concept, and the main idea was to push concepts into C++ 11. Back then it was called C++ on OX. It was OX because they aimed to push it on as 2010, but they didn't make it. The problem about concept back then was that the compilation speed was terrible. It was 10 times slower than right now, and right now we are saying that the compilation time is bad. And back in the days, compilation time was even worse because we were using template metaprogramming, many hacks, and additional the compilers were kind of not that good. There was, the main one was GCC. There was a lot of branches, other compilers, but you know, now we have Clang, GCC, and the improvement of compilers is great. We have every feature before it comes out. So like the concepts, I was fiddling with that on 2018, and it is not even yet in the standard. So that's a great thing. And the other side was that the documentation about the concept was huge, tremendous. They couldn't create the proper interface for that. To be specific, I think it was like 70 or more pages for 130 concepts. And it was numerous times more than the whole documentation about templates in the standard. So that was just bad. And they, unfortunately, it didn't push it, but it was good for the language. Then concept was about to come into 70, C++ 70, and this was kind of a must. Everyone was hoping for that, and everyone thought, okay, we had like, I don't know, 15 years to develop that. So let's push it. So let's push it there. And I think, and everyone thought that this is going to be a fact. Unfortunately, there were some changes at the very last steps of the committee standard. The committee has very strict rules, but this is good because then we know that things that are pushed are really working. So we need to wait 3 more years, and now we are in 2020. We can really make use of that. Okay, so that's the history. Sorry for a long introduction, but I think it's kind of a nice. And one more thing, going back, I didn't say much about what this presentation will be. So I'll provide some live code. I said that, but it won't be the one where I will teach you how to really create and construct a concept. I will just, in this one, this will be short. I will just provide the idea of a concept. We won't even create many of them. I'll just show you how it is done, how you can eat it. So it will be an introduction to the next one, which I hopefully can create, but we'll see. So we need generic programming, and why? So most of you probably are not using generic programming, generic programming, so template programming and so on and so forth. And why do we need that? Mostly because currently most of the projects are based on inheritance. Inheritance were taken mostly, so object-oriented programming was mostly taken from the Java world when Java was very popular around early 2000 and early 2010s. And most of the coding patterns were created in the Java style. So there is a lot of inheritance, there is a lot of virtual functions, v-pointers, everything. And it has a great impact on the performance. And this is kind of strange because right now, why we are picking C++? We are picking C++ for the performance, and we are using it in the very different way. So that's why I think, and I will show you why, I think it should be changed. Moreover, we should be more adaptable to the future changes. I will show some snippets of the code. We will write it together to the other point later on. But most of the code we are writing is dependent on some interfaces, again, virtual calls, or are just plain functions. Plain functions are okay, but they are hard to be extended. You need to have overloads, different sets for different types. So for floating point, like float or double, you have to have a different most likely different methods. And this is creating a lot of code, which is really very hard to maintain in the future. And this is funny because most of the guys say that templates are hard to maintain. This is very not true. Templates are very easy to maintain if they are written correctly. The problem is that current syntax is very bad. I'll get back to that later. Moreover, the code which we write should be testable. We can achieve a testable code by using the virtual calls, so the inheritance and stuff like that, in most cases. But probably most of you had to create unit tests. And the unit test coverage had to be, I don't know, 80%, 90%. If you had to have 100% and you had a client code base, then I really feel sorry for you, because you had to, define a lot of hacks, tricks to get the proper coverage. And this can be done easy with templates, to be honest. Compile time checking. So this is very much connected with the performance noise, but additional with error checking. So in C++, when we use templates and static assertions, we can define some boundaries where you know that the program won't compile, even though it would possibly have some runtime and not compile time errors. So you can check for the size of any construct's value. So that can be a size of a buffer of which you can, for some reason, overflow. So this is a very nice thing and very wise to use. So it can, save you a lot of headache in the future. The code is more intuitive because there are no relationships, as the next point says. There are no relationships between the modules. So you're just taking something and you use it. You don't care whether this is interface of A, B, C, what part of the inheritance it is. It is just, let's say, a callable. So what do you do with callable? You just call it. You don't care what it does. It doesn't matter. For the point of architecture, it doesn't matter at all. It just has to have some interface on which you will base. So there is a template design goals, because templates were created in 1987, as I said, by Björn Strostrup, and his main idea was to create general code. So he wouldn't like to have a lot of boilerplate for doing the same functionality. Like in C, you have to have either void pointers and you need to cast it to gain some functionality, or other way, you just need to create different method for each and every functionality. There should be a zero overhead, because what is the point of creating a new functionality when we have the virtual calls, the vtable, and this is, if we wouldn't care about the performance, then templates are done. They are not needed at all. Just stick with the things that we have. And well-defined and easy to use interfaces. And this is kind of a joke. Let's see what we've got. So we've got kind of a pro generality. We do have zero overhead, and in fact, we have better. We can do better than zero overhead, because we can put things into compilation time. So we are not wasting anything. We are gaining additional time. This is a great thing. So the interfaces are terrible, and there is one more thing about those interfaces. They follow the DAG theory. If you don't know the DAG theory, there is a Wikipedia which says that if something looks like a DAG, it swims like a DAG, and quacks like a DAG, then it must be probably a DAG. So this is the very same situation with templates. We just take type name T, and we are not checking any constraint. We are applying that, okay, you gave us that type. You need to take care about its compliance with the needs of the interface. And most likely, most of you have seen the templates errors. They are terrible. The compliance got better. So now we can have something what is readable, especially if you have some experience, then that the error is there. Don't worry, and the compiler will pretty much say what is going wrong. But he will point every single type in the inheritance with the static inheritance or with the chain of library, which is converting every time. And then somewhere in this chain, you will see the error you are looking for. So this is really not the way to go. And this is the main reason why people are going against template, because this is really too hard. You know? What about concepts? Concepts are compile time predicate. But maybe I'll show you the code about. I'll show the code which I've written, and I can show you why templates are better. This is the correct time. Sorry for switching. Okay, I was about to create some charts and design of code I'm presenting you right now, but it slipped on my mind maybe, and I didn't have that much time. Sorry for that. So we'll go through the code very easy. So this is the code which you will probably most likely see in the production. The code snippets I'm about to show you right now are idiomatic. They are simple. They shouldn't provide any, they are not following the good practices of the code. So this is just for the presentation. Maybe that's not the best way to present the code, but this is handwritten code. Maybe you will see someone written by someone like a junior. So what is the aim? Let's say we have some communication between clients, between two objects. One object is a client, and the second object, let's say, is a server. Server is a placeholder, to be honest. For the easiest of the naming, because naming C++ is always, in general in programming, is always the hardest part. So let's say we have a client and a server. So let's say the server is triggered by someone, and then if the server is triggered, then he is broadcasting every single client which is registered to him. And this is done by me. This is done very easily. So whenever whenever a server is triggered, then we are sending tick. So showing tick, and all of the clients which receive the broadcast are showing talk. So very easy one. Okay. So first, if you will go through the object-oriented pattern, we would have to create some interface. So the client has very simple interface. This is just a notify. So server is notifying the client that, okay, I'm broadcasting something to you. We don't care about the message. This could be extended with the message type, and then we could do an overload, but we just really don't care about it. We have, say, message-less queue. And then there is a server. I've created a interface of the server because I don't know, I can have multiple servers. The one who's triggering me can, trigger multiple servers. So, or I would need to stack those servers in the vector. Everything has to be done like that. So hard for me to say. I've created the interface. I'm creating the client foo. This foo client is of course inheriting from the interface. It has some default construction distraction. This has to be virtual because of the inheritance, of course. And then the notify is just printing, okay, I'm client foo and I'm sending you a talk. I did the same thing for the second type of a client. Let's say this client bar. I'm using the foo bar naming because this is very popular in doing dummy code or presentation code. So I'm following that. And again, this is the very same. The naming is just different. So you can say you can see that this is not applying the dry. Sorry, I got it in the tip of my tongue. It is not going through the dry pattern. So dry pattern means do not repeat yourself. And we are clearly doing a lot of boilerplate, doing the same thing. This can be, of course, even with the inheritance, this can be done better, but I'm trying to do a bad code style because this is the most code I see in production. And then there is a server. Server is also inheriting from the interface, his interface, same stuff as before. And now we have a trigger. So a trigger is showing a server foo. So the name of the server, then the tick, and we are notifying all the members that are there. Moreover, let's see the interface. The interface for the server is a trigger and register client. So first we need to register clients. Registration of the clients just takes the unique pointer of our client because we have just a single client. The client is in a single server, so we can use a unique pointer. If it would be otherwise, so one client can be multiple servers, then we would have to use short pointer. That's just obvious stuff. And then we are just going, we are pushing to the vector, and the vector is just a vector of unique pointers. So simple stuff. Here is the second server, but I'm not using it for the sake of this presentation. I've created it probably automatically, but this is a good pattern to show how the code is created. Many of the time we are creating things that are not used and producing a dead code, which is then removed during unit testing. Okay, so what it does really. So this is really easy case. We are creating foo, client bar. Then the server is created, server is registering both clients, and we are doing the trigger. So this is what is presented. Very easy case. There is a lot of code for that easy case, for the footprints, but let's see the assembly. To be honest, I'm not the god of assembly. I'm not working with that too much, but there is one simple scenario. The more assembly there is, the worse the code generated is. You can see how many assemblies here. There is tons of that. And remember, this is just triggering single for and printing 3 values. So this is kind of bad. And this is like an object-oriented pattern doing things. Of course, some of you may say this can be done better, of course, but this is not great. Therefore, we can just make it better with templates. Take a look at that. I've already done the implementation because probably the time wouldn't be good enough for me to do everything, but there will be some parts where I will be really coding with you. So here, there's a lot less code. I will explain it line by line in a second. And here you go. There is like nothing of assembly. Every single thing in this is compile time. So the compilation really takes longer, but the runtime takes like nothing. We are not doing any operation through the runtime. Of course, this is kind of a very dummy example because we know every single part of the program at the very beginning of it. So during the compilation, this is not really not the real use case, but there are use cases when you, for example, has variants of the programs, and each variant has different business logic for some parts. And in most cases, we would do it those ifs and switches in the runtime, and here you can do it in compile time. There are my friends were some time ago were asking me about some enhancements to their code because they can see that they saw that they have variants which are compile time and they are wasting the CPU time, and performance is very important, especially if you are doing C++ and you are embedded. Of course, nowadays everything is embedded, and maybe it's not like computer in the automotive industry. Most likely it's not embedded, it's just regular Linux, but still you have tons of services, and each service is taking some time of the processor. And if you are having scaling that by 1,000, 10,000, or something like that, then every millisecond is taking account into that. Okay, so what it does? We can remember that we had a server and a client. Server is no longer applicable. I mean, the interfaces are no longer applicable. We are using templates. We don't want the virtual inheritance. this is breaking the code. So the interfaces, which were here, are no longer needed. So we just need a client and a server. So what the client does. Previously, the client was using his interface and sending the notification. So this is the code which was different by client var and client foo. A lot of boilerplate, if I would tell you, for just different printout. So here we did it kind of differently. So the aim is that we are getting callable, and this callable will be called when there is a notify. The notify comes from the server. Why I don't need an interface here? Basically because of the template duck typing. Template accepts anything that I pass to him, but he will throw a compilation error of a very, very bad case, a very bad printout when something goes wrong. So you need to take care of the things that you do. Okay, so this is a callable. Callable from my perspective is the thing that can be called. Very easy stuff. I'm assigning that to the notify. So this will be probably a steady function, but you can define your own. That's the beauty of the templates. You can create your own type, and it will work if you have overloaded operator of parentheses. This will just work. Whether this will be a struct, regular function pointer, or std function, lambda, anything will work. So that's the client. So very easy. And it will work for both cases. And here I'm just assigning the value what I get from in the constructor into the notification. And here is how I'm initializing that. Very easy. So I'm passing the lambda. This lambda doesn't getting me anywhere here because it doesn't need any parameters because this is generic lambda. So not parameter less lambda. So I will speak about generic lambdas as well later on. So I don't need anything. I'm creating the same for the bar, but the printout is different. Then let's get back to the server. Server is using variety template, very easy. And the server is then getting a lot of clients in the template parameters. So this is variety. We got tons of clients. So this can be 0 or infinite number in theory, because we are in computer, so we always have to have some limit. And then we are assigning that. Here I'm creating a tuple. I've changed vector into the tuple because vector is doing the runtime, and I would like to have something that is static. So I don't want anything to be runtime. Tuple is like, for sake of the easiness, this is just a static container. Very easy. I'm forwarding the tuple as forward as a tuple just creates a tuple of references of an object to the tuple. So we have the reference of each client here, and then we have a trigger. Each of the call is context because we are doing that in compile time, and the new features 17, C++ 14, 17, and 20, they are making as much as is possible as a context. So I'm creating a trigger. Trigger is doing the same thing. We are printing the server tick, and after the printout, we are just doing the std apply. This is a standard algorithm. This is the standard algorithm from the STL, which is taking numbers of clients in the lambda. This is generic lambda, in fact, so we can use an auto here, and I will speak about it when I'll be speaking about the concepts later on. And then we are just, using the fold expression. Fold expression is the easier case of providing the same operation for all of the variadic arguments. If you wouldn't do that, here I'm not using any, I'm using everything from C++ 17 and 20. for the case of, you not have to see the very ugly C++ code. But if you like to see that, I can check one thing. No, I've deleted that, I think. Anyhow, maybe later I'll show you. You would have to have many instances of the same method, getting different amount of template arguments, and then when you have just one template argument, you are done. So this is the end scenario, but this is not very nice. So this code is extremely simple, as you can see. And here I'm just triggering the stuff. Here everything is in compile time. I don't know, maybe this is me, but here there's a lot of code. There is a runtime overhead, a lot of runtime overhead. And there's a lot of boilerplate code. And I really don't like it. I think this is a neat one, but probably this is because I'm more used to the templates. It can be done better, of course. But here I said about the duct taping and about the errors in the C++, and I will show you what I meant by that. So here, this is a duck. I would say, let's say this is a duck. I think it quacks, it walks, and swims. It's a duck. But if I would pass here something else than the client I provided, then I have a very nasty error. This error is not that nasty. I'll show you later on something which is terribly worse. But yeah, those are the template issues. I'm not even going to show you what's the case for that. The main problem here is that I'm giving there an int. First thing, there is an int, but okay, let's say that's fine. Second thing, the most important thing is that this int has to have a notify method, but it doesn't. And because of the duck type, it is very hard for me to really check that. Let me just copy one code snippet. Just a sec. So this is C++. These are C++ templates. This is the way to check that the in the Sphinx, I told you don't need to know about the Sphinx. But I'm just going to show you that this can be done this way, by checking whether the P which I'm providing has a notify method. And later on, I will show you how it can be done using concepts. And then we'll see what's really better. Here, I can just very quickly go through that. So this has method notify. This is a base case. Doesn't really matter. It's taking T, so the type to check. ID type is the type. The naming is bad, but this is the type returned by the notify. And then there's a void T. This is kind of a magic for the metaprogramming. Someday maybe I'll speak about it more if we have time, and not a presentation, something like that. And then there is a has member notify. It has to, this is like a partial specialization of the has member notify here. The first case is using the standard library and always providing a false, because when we are checking the constraint, we always need to have a Boolean, whether this is true or false. This is how everything is checked in C++. And then we are doing some magic. Here we are providing the types that are needed, so key, ID key. And here we are using this void T, so we are doing some magic, which I won't explain that much because it's not, it will take me another 20 minutes. It's not the point of this talk. And here I'm using decal type. Decal type is returning the type of an object. then inside I'm using the declval. Declval is doing instantiation, is creating object from the type. So if I will put here an int, then I'll create a type of type int or of type of my class. So the very easy case here, and then we are creating this. We are using this declval of type T, so of the type we provided, and then on this type, which is already instantiated and created, we can call the function. And the whole magic about the templates is that if you are not able to do something, then the template are providing you either an error, compilation error with the information that something is wrong, or they are trying to inspect another type. In this case, it is not printing an error. This is evaluated into false. And here we are also checking condition. So the conditional, we are either returning true, or we are returning another Boolean expression, which is, I can see that there's QA. Where you want me to add the, there are optimization flag, I think. Yeah, they are. Here, there are not here. Yeah, correct. You're correct. Good catch, sorry. Yeah, we can check what's going on here. Okay, still. If you wanted to prove something, then it didn't really work that way, that good. Still better, but still, it's not compiled then. You can see there is a lot of vtable, but still better, of course. But then compare it with the compile time unit. You know. Okay. I'm getting back. Sorry for the long introduction. We didn't even touch the concept, but as I said, this is very hard when I'm doing the webinar because I don't have interaction with you, not the strict one, and I can't see the Q&A session that easily because I need to drop that. Maybe this is probably this is adjustable, but I'm just, you know, I have no idea about it yet. Sorry for that. Okay, then yeah, and then we are just checking whether the remove reference because I don't want any reference. I just want the bare type. I'm doing the same thing. I'm checking type of the instance of the key, and I'm doing the notify and getting type. And this one returns me the information what it returns, what the notify returns, and I'm checking that with my ID, and then I need to get the value, and then I need to do the condition whether if it's true, then return me one thing, the true type. If it is false, return me the second thing, the false type. I really need to get quickly because I wasted a lot of time. Sorry for that. Hard to catch the things when everything's going like that. Okay, so this is how we would do that before. And then I could use Spine. I don't have time. I won't write that anymore. I will use Spine. I would use Spine, or I would just use a static assertion. I can use a static assertion. That would be best to use inside of a class, but then I would have to do some magic with. I would need. Let's see. Then I would need to do some extra magic. And then we can just use this helper, which returns the value of, and here we are providing just a key. So let's say I'm gonna provide it in, let's say, local type out of, maybe not out of one, but let's do it like this. Kind of idiomatic as I said before, and then we can do the declaration of that. And, you know, check whether the value is correct. Static assertion failed. You can see that there is no type of no method of type, and then the error is not really that good if we compare it to the one created by the client. But still, if you would have a great, some very big error, then this will be pretty much nice. So this is it, and then how concepts are about that. Sorry. Okay, so let's get back to the real business. So the core of this presentation, of which already took an hour, I didn't tell you much. So concept is a compile time predicate. So this is taken from Bjarne Strostrup article when he was speaking about the concept lights, I think, or the concept in 17. And basically the idea of this is to return a Boolean whether the precondition is true or not. So in most cases, this is very similar to the things that are done by the type trace, but it is tremendously easier to do. So then this is the very basic of the introspection. We can check whether the things that we've created doesn't really make any sense. Whether our code is created in the way that we expected to that. And in my opinion, if I speak with, let's say, with an architect or with the developer of someone else, then I would like to speak about speak in the way that the code is created. So if I tell you that, let's say, take back the client server example, then if I tell you that, okay, there is a client, the client is doing some stuff, maybe taking a callable or invoking anything. The client, let's say, is invoking anything, and then the server is having the list of the elements. This element has to have notify and nothing more, basically, and then it's good to go. And then whenever you are triggered by someone who knows that you are having the trigger method, you shall do the thing that you print something, let's say this tick or talk, doesn't matter, and then you are doing the same for, and then you are notifying all the clients that are concerned, that you are concerned. This code is more likely to be understood, in my opinion, maybe that's just me, by other developers, by someone who doesn't have much experience. You don't need to think in the way that, okay, I need to create interface 1, interface 2, client, server, maybe what goes if I would have to downcast, upcast, change the interfaces, what's gonna be needed. And then, of course, there is a thing about performance, which I said too much. And then we don't have to use this very ugly replacement, this very ugly stinate. The thing that I showed you is not even that bad. Normally, you have to use always enable if, and this is even worse than that. So, open up that screen. Sorry. This is the syntax of a concept, and later on we'll just go through the code and just write the stuff that we need. So, concept is defined in the way. This is just a regular template, and here is the concept. So, that the way we write a concept is that we need to create a template-like type name and use that keyword, unfortunately, but this cannot be really changed. Then we are using the concept we are using the concept keyword, then we are using the name of the concept, and then we need to provide the predicate. I'll show you some types of the predicates just in a minute. I will write them down. Hopefully they will compile, I hope. Okay, and then, so that's the one way. Then we can directly require, which concept has to be involved, let's say checked, statically asserted for each type name, so for each template call. Then you can just provide, you don't need to, in your template code, you don't need to provide a type name anymore. You can just say, okay, foo, or T of foo. So the T has to meet the requirements of my, my predicate. And it does some magic. And the last and best for me, I think, you can create better autocode. I didn't create a slide for that, and I'm not that very good at slides, I can see. But the main problem with our code right now is that everything what is auto might be commented as a hard to read, especially if you are creating some return times of the function, and you really shouldn't care about what is returned, because the function today may return an int or an interface or something like that, but tomorrow it can change. And then if it will change, then you would have to run the cascade of fixes, and very small type change can create commits of thousands of lines of code. Even though, for instance, the logic didn't change at all, but you just had to change the type. And if you use auto, it would be okay, but still some might say you don't know what is up there. Okay, so let's go through the code. To be frank, I wasn't able to make time to create those concept slides, so whatever I will write right now will be just created at the moment. So probably dragons can happen. I'll create a new okay, we're still, I'll just delete it. Doesn't really matter. And I'll just also say something about the errors. Let's assume that you will use the std list. This will be very quick. And how templates are bad right now. Let's say that you are trying to, or maybe vector. You are trying to create a vector of reference. And then you will see, this is the newest compiler, we'll see what happens, but it should provide you a lot of bad code. So, okay, have fun really playing with that. If you don't know that, you just really can't provide a reference into the vector. So this is terribly, terribly bad. And here, we can just create a concept. So as a side note, there is a concept library. This is a concept library, and in the concept library, standard library created a lot of concepts, which I will show you in a minute. I didn't create a slide for that, as I said, but we can use a lot of them and really make our code easier. So, as I said, to define a concept, we need to create just a regular, like a regular template. Let's say use type T. We shouldn't use that kind of a wording, but for now, this will be, let's say, easiest. Okay. And this will be a concept. This concept is going to be let's say, is object or object is object can be. And then we just can use std standard library is object, and we can just need to open the reference on the side. Okay, then we can just do something like that. Because the problem is that the int doesn't match because it is not an object, as I said. So we can use the type trait. No one asked the question. And let's say of t. Okay, concept is correct. Then if we would, let's say, create a new class or maybe a struct, struct will be, which will create a wrapper on the vector, let's say the vector, and what it really does, let's say we want to provide the information, we want to just provide the type down into the vector. So let's say this will be type name vec type. This is how we would do that previously. Something like that, and this then if I change that here, and you know, everything is still bad. But if I'll do something like that, yes, okay, so compiling. So here the error is definitely better. So you can see that the constraint is not really followed, that we are doing some stupid thing, and you can really see that what is going on here. Okay, so let's change that into, let's say, int. Okay, so that's one thing about it. We can also, as I said, use this concept like that. And this should still work because, as I said, we can pass that differently. Okay, it should work. It's taking some time. I'm not sure why, to be honest. Okay, so this is, you know, 10 times easier than it was. Okay, then we can also check whether type has some, let's say, a method. So we can do something like that. Oh, sorry, someone is doing the renovations above me again. Okay, then we are doing the concept, and then let's say this is very bad naming, but has method, has notify. Let's say I'll maybe get back to that example of mine later on, but doesn't really matter. And here, if you want to check the constraints about some type, then we should do requires, and we need to provide what we are really using here. So here I'm using type T, which is in fact an object, a client, or something like that. For us, it might be a client. And here I'm just, it looks like regular struct or something like that. I'm opening the parentheses here, braces here, and here I can create some strings. So in that case, I'm using the same braces, and I'm just trying to invoke on the client, I'll invoke notify. And then we need to show what type it will return. This is kind of mandatory. I hope this will work in GCC 10 before I was using Clang. So maybe I should have checked that before. Notify does nothing, but okay, it can be bool, doesn't really matter. Whether this has a notify, it's not the problem scope. Okay, so this is a concept. If I would create here a, let's say, additional notify method, so bool notify, and it doesn't take anything because it can't, and yeah, returns true whatsoever. It's not the point of that here. And has notify. So I can check that. For now, I'll exchange the names of the concepts just for now to check whether this is true or not. Yeah, this is it. So it's gonna do. But for instance, if that would be a struct A, let's say. It shouldn't be here, it should be here. It's correct, my fault. Okay, has notify, and here I'm using nothing A. And then let's get that. So it works. I'm checking how really I can change that, and I don't know if I have it here. So you can really do some. You can take a look how much simpler that is. So this is the very same code to check the notify, and this is the very same code to check the notify here. Moreover, I can check more things at the same time. Here, I can check whether it is an object. It should be requires, I think, subject. I used different notation before. Okay, it works. So now I will check that A, first thing is an object, second thing has a notify. 2 lines of code. Here, probably I would have to create definitely more than this to replicate that. And for each of them, I would have to create special case. So here, this is extremely easy, if you can see. Then I also told you that there are types that are already defined in the C++ concepts. I mean, the concept already defined, and I will show you in a minute how you can make some STL algorithms or copies of them way easier than they are done before. And moreover, any concept can be used with each other. They can be used with disjunction, conjunction. So I could create something like so very bad naming. Plus T, let's say, object with notify. And then I could just use the has notify and this object and has notify here as well. And then I can use it here. Same stuff. Should be fine. So this way you can create really big ones, which really have a meaning there. And moreover, I told you that there is, sorry, it's taking definitely long, more than an hour right now. I hope to do it in 30 minutes. Sorry for that. Next time will be better. By the way, this is the first time I'm doing that. I really wanted to do that, but I'm doing it for the first time. So we are the beta testers. So we are the poor guys, which really had to go through all my talking too long, and moreover, I couldn't see your faces, anything like that. So sorry for that. Okay, so let's create a very simple function. Let's say that's going to be max value. This will return as the maximum value of two things, let's say, and we can do auto, and then so we can do auto, and then we can do here we'll normally you will do something like that. Type name T, so both types has to be of the same type, and here we are doing A, B, and whether if A is bigger than B, or we can just use A bigger than B, then return A, and then return, otherwise return B. So very simple stuff in one line, just to save our time, maybe your time because it's wasted already. Should be fine. Okay, so very simple stuff. And here you might find a problem if I would like to use my structure A, and then you know, I'll try to use that on structure A. Because of the ADL, I don't need to provide types when I call the function. So that's going to be, let's say, A and B, for instance. And then I will just return no questions. Less and less people got it. I'm getting to the end eventually. Sorry. So A and B, the return variable right now is not really needed because it won't work anyhow. So let's wait for the completion. It's taking time. I don't want to mess anything like that. But this is obvious, it won't work. Oh, sorry. So this is obvious, it will not work due to the fact that there is no way we can really provide some, we can really, the operator for bigger equality and stuff like that is not provided. So we really can't do that. So what we would have to do if we were using concepts, then we would have to create a totally ordered operator. So this will be kind of a more sophisticated operator, which we'll use. So totally order means that A can be bigger. So if we have, let's say, this will be a pseudocode. If we get TA and TB, then if it is totally ordered, then it means that A can be equal to B, and this will be bool, and also B, A can be different than B, which will give bool, and etc., etc. So A can be bigger, A can be smaller, and A can be also equal. And B. And all of them has to return bool, of course. And then if everything passes that, we could just say that those operations are correct. But we can do that with concepts right now. So the easiest way to do it would be to use template. Type name C. So that will be the type which we will be checking. This will be a concept solidly ordered. And here we are doing requires as before. We require two values of the same kind. To be true. No, sorry, this is not needed. So that's the first thing. And then here, don't use var types. I think Clang really accepts you that, but it's convertible to bool because there might be some types which are convertible to bool, but they are not bool. So this is, and I can see that C doesn't work that way. And then if those types are, all of those will work, then it should basically work. Compiling still. Compilation for it. Just a sec. Okay. Semicolon at the end. Right now you have the advantage because the working standard is done. Before, when I was learning, the GCC had different standard, Clang has different standard, everyone had different standard, and using different compilers brought you different results. So here we can just say that this is totally ordered, as I said before. So then it should be definitely better. Constraint not so satisfied. So still the error log is big, but it gives us every its and bits of the things that are not really possible here. So this way we can really provide the information, and here we can also do it differently. So we can pass the info about the template, and we can just use different type of. We can use auto. So auto, like in the generic lambda, but it will not work that way as easily. And we can just provide here the information that we are using in auto, but narrowed to the totally ordered type. And we have the same error. Moreover, I will not speak about it because this hour and a half, and I wanted to do it in this 30 minutes. I don't know why it took me so long. Sorry. Sorry that I'm sorry that much, but it's strange for me. So here I could also create the same thing for maybe I'll show that, but or not. I'll do something like that. So A from and let's say max value. And then I could narrow the information. Sure. Maybe we can do something like that. And this will work. Then I can always narrow things which are returned. Compilation failed. Okay, redefinition, okay. And then I know that the type which is returned is totally ordered. I know that the type which are inside is totally ordered. and then you can create anything with those types. Okay, so this is all from me right now.